So let's talk big picture about mass spectrometry. I love mass spectrometry. I did it as an undergraduate and I worked with quadrupole mass spectrometry, QMS. Big things I want to give you in this video. First of all, what we are focusing on with organic is a teeny tiny slice of the mass spec field. I have a great book by Jürgen Gross. It is an amazing book on mass spec, and everything we talk about organic basically constitutes one, maybe two chapters in this 14 or 15 chapter book. So don't look at mass spec from an organic standpoint that this is all there is. There is a lot to this technique. It is a really cool, really powerful technique, but kind of like most of organic analytical techniques, we want to start with the cheapest ones first before we move to the really expensive ones. So specifically, we're going to look at electronic ionization, quadrupole mass spectrometry, or since you're getting cheap enough now, you'll probably hear octupole mass spectrometry, OMS, QMS. These are the workhorses of labs. They are cheap and they are great. Now, frustration I had later in life, because when I took organic chemistry and I looked at these mass spec pictures, basically all we were doing is saying, okay, there's the heaviest atom, or there's the heaviest peak, that's the mass of the parent compound. And it's good for calculating molecular weight. But what I want to emphasize to you is things I wish they had taught me in organic chemistry, specifically that you get this whole spectrum. There's so much information in it that can be used to verify other components of your analysis. So pair with your 1H, your carbon-13, and your IR, you can basically verify everything you've done is correct. So we're going to go a little bit more in depth than most books like to go into, because this is something I really find lacking from an organic curriculum. Now, that said, are there limitations to mass spec? Well, yeah. The practical one is we have to do a separation. So you're gonna work with mass spectrums, but here's the thing. There is a whole front end associated with a mass spec. It's usually what's considered chromatography. So gas chromatography, liquid chromatography, ion chromatography. There's things that are out there to separate our compound out from the solvent that it's in, to separate out from the other byproducts. So the mass spec is an oversimplified picture. The second is that there is a lot of theory that because we have optimized mass spec, specifically quadrupole mass spec or QMS, it gets kind of lost and forgotten that it's there. The practical thing being how do you set the machine up and how do you make sure it's working correctly. There are other mass spec techniques that if you start getting to higher course, usually people begrudgingly say, man, I really wish we cover those. That's because they are more powerful techniques, but again, they're more expensive. The big one is MALDI, matrix-assisted laser desorption ionization. If you want to know the mass of that parent compound, MALDI is the way to go. It's one of the best techniques because the parent ion may not be stable enough to measure in sufficient quantities. So, last complication with mass spec, we do have isotope effects. Deuterium exists, 2H exists, carbon-13 exists. Isotopes exist of all elements, and because of this, there's going to be some little details that show up in the mass spectrum that you need to be aware of. Again, we can lose those details because they don't really deter from the big picture, but be aware that they're in there. So, this is your primer on mass spec. It's there to tell us the weight of the parent compound, and it's there to tell us what functional groups are present, and it's there to kind of dovetail with all our other analytical techniques to verify we got what we think we made.